Everyone, welcome to your geometry play posit for the week. This week, our play posit's covering similar figures. This is going to be the last lesson in Unit 6 and the last lesson for Semester 1. So go ahead and grab your notes, have your OMHS play posit graded assignment open, and let's get ready. One thing about this, grab your notes. So remember that if you use the guided notes that I provide you, they are in that same exact folder where you clicked to open this recording. Just a few reminders. We've talked about this already, but in case you missed it, you guys have those practice USA test prep assignments. There are 3 of them. Those are for a grade. Each of them are 2 points. You guys have probably noticed the grade items in your grade book. And so if you see any zeros for those, please log into USA Test Prep and make sure you have completed at least 3 of those practice assignments. These were assigned before winter break. These were assigned around December 4th-ish, I believe, and December 11th-ish, I believe, on your plan. So this is not the practice exam. These are just 3 little tiny practice assignments that were assigned over the month of December. Second is our semester 1 end date. That is coming up. That is 2 weeks from now, January 22nd. So just like our first end date, after January 22nd, you will not be able to access any of those assignments that happened before. So make sure you have no missing assignments and make sure that you've used all your attempts on your quizzes and your tests if you wanted to retake anything. And as always, reach out for help or questions. Don't forget about office hours with me. They are on Tuesdays at 2 o'clock. And then we also have an extra help session with Ms. Jadala on Fridays at 11. So there are 2 opportunities for you outside of class to get some extra help. If neither of these times work, you guys can always just reach out to me as well. And we can always look at getting a one-on-one session on the calendar. Your semester exam is on January 19th. This is covering everything from units 1 through 6. There is a practice test available for you in USA Test Prep. You can take this an unlimited number of times. It is not graded. However, I encourage you to do the very best you can because this is going to be as close as you can get to taking the actual test. So if you put all of your effort into it, you're going to see exactly where you might need to study some more, what areas you might need some more help with. So definitely take it seriously. This was just a list of times between when I put the practice exam in USA Test Prep and the 19th when you could get extra help. So our office hour last week actually was moved to Friday, and I saw 3 people there. Thank you for coming. I would love to see more. And then we'll have another office hour on Tuesday, tomorrow, if you're watching this on Monday. And then last Friday, Mr. Dalla had a help session, and next Friday she'll also have a help session. And then I added another help session on that same Friday at 9 o'clock. So there are a lot of opportunities for you guys to get some extra help and review. So remember last live class, we were talking about similar shapes. And similar shapes are shapes that are the same shape, but different sizes. Same shape, different sizes. We talked about that definition last class. So I can just give some examples here. Let me use the good old triangle. So you can see that this is the same shape, right? It's a triangle, but they're different sizes. So these are similar shapes. So there's more to it than that, though. The thing about similar shapes is their angles, that's not a very good color, is it? Their angles are congruent. And their sides are proportional. Remember we talked about proportions. A proportion is just 2 fractions set equal to each other. So if we wanted to call this, just for the ease of writing, we could call this ABC. We could call this DEF. And to show that the sides are proportional, we would do A over D equals, there's this side over this side has that first ratio. You match up the sides, B over E and C over F. And it's really that easy. The only thing you want to make sure you definitely do is make sure you're going from the same shape each time. So all of our numerators, all of the numbers on the top here belong to triangle number 1. And we're going to triangle number 2. So triangle 1 over triangle 2. You don't want to start to mix and match them because that wouldn't make mathematical sense. You want to make sure you're going from the same shape each time. So if two shapes are similar, then these ratios will hold true. They'll be proportional. And let's look at an example. It says, are these similar? So we have a test. Let's see if they're similar. We're going to do 20. I'm going to go shape 1 to shape 2. It's up to you. You could go shape 2 to shape 1. 20 over 25. So we're matching up the parts. This is obviously the top of this one, right? This shape has been flipped upside down. And then 28 over 35. That's the other base. And then I'll do the left side over the right, or over the left side down here. And lastly, 12.4 over 15.5. You might look at that and be like, okay, well, what does that mean? So let me get the Desmos calculator for us. And if each of those fractions, if each of those ratios end up equaling themselves, then we know we have a similar shapes. We know the sides are proportional. So I'm going to put that on my other screen. You won't be able to see it. So 20 divided by 25 is 0.8. 28 divided by 35 is also 0.8. Looking good so far. Let's see. 12.4 divided by 15.5 is 0.8. And 12.4 divided by 15.5 is also 0.8. So you can see that all of these ratios are equal, which shows that the sides are proportional. So yes, sides are proportional. And the angles are equal, right? We have these tick marks showing that they're equal to these two. We know that they're not all four going to be equal because, because of the shape that we have here. All right, let's look at another example. Are these shapes similar? I mean, they kind of look similar. They look like the same shape, 4 sides, but let's see, let's make sure. And to do that, we're going to set up those ratios again. So I'll do 8 over 10, 14 over 21. I'm just taking each of these pieces and like matching them up. 9.1 over 16.7 and 9.1 over 16.7. So obviously those are equal. Let's see about 8 over 10. Well, you guys know 8 over 10 is 0.8. 14 over 21. Ooh, that's 0.67. So we've already found a counterexample. Those are not equal. Let's just get these last two sort of simplified so we can see. And these are both 0.54. So no, they are not similar because the sides are not proportional. Sides are not proportional. Look at that. You can write off of the slide. That's great. That's perfect for me. All right, so let's just review how to solve things like this. There's kind of two ways to do it. When we think back to Algebra 1, when we're trying to solve for x, we're trying to get rid of whatever is with the x. So, there's a 1 there. So it's a 1/3 that we're trying to get rid of. Do you guys remember the inverse operation of a fraction, or the opposite of having a fraction? What would we do? We would multiply by the reciprocal. So it would be 3 over 1. Multiply by 3 over 1 on both sides. And that's going to get us x by itself, right? Because the 3's divide out and the 1's divide out, so you just have x. And then over here, we would have 21 over 5. There's another way to do it. And you may have heard the term cross multiplication. So we can do 5 times x equals 7 times 3. And then continue to solve for x. So we'll divide by 5, and you can see we get the same exact answer, 21 over 5. So it's kind of up to you how you like to do it. The first way is the one that I know that we definitely learned in Algebra 1. The second way might be new to some of you, cross multiplication. And you can see it makes a cross in the middle, or like an X. So let's try this example, and I'm just going to do cross multiplication. You can do that when you have two ratios set equal to each other. This is one way to solve a proportion. So 8 times 3 equals x times 4, or 4 times x. So we end up with 24 equals 4x, and then we'll just divide both sides by 4. Wow. I don't know why my 4's turned up looking like 9s. Let me fix that. And that is 6. So x is 6. So we're going to use cross multiplication to solve for some side lengths of some similar shapes, which is exactly what this is. Using similarity to solve for the missing side lengths. Oh, they're so similar. So cute. Valentine's Day is coming. Gosh, I kind of forgot about that. We're going to use proportions to solve for the missing sides. Remember, a proportion is just two fractions set equal to each other. So we should have some information here. Assume shapes are similar. You might also see it written, like if I give these some labels, E, F, G, H. You might see it written A, B, C, D is similar to E, F, G, H. So this is a similarity statement. We've seen congruence statements a lot, and similarity statements work the same way. It matches up the angles that are equal, A and E, and it matches up the sides that are proportional. So AB would match up with EF. AB and EF. So let's try that. I'm going to put an X here. You could keep it a question mark if you wanted to, but I'm just used to seeing an X, So we're going to do X over 24. Come on, 4. Did you guys see that? X over 24 equals, now we have two choices over here on the bigger shape, but we only have one over here. So we have to use the 10 and then match it up with the 15. We could not use this 15 for anything because it doesn't have a partner over here. All right, now we can solve the proportion using cross multiplication. So 24 times 10 equals 15 times x. So 240. And then we're just going to divide both sides by 15 to get x all by itself. And that is 16. I put that in the calculator. There we go. And if you wanted to check yourself, you could. We could plug 16 in for x up here in this fraction. Man, that 4. And then we would just sort of check it like we did those original ones. Let's see what the decimal is, and they better match because they're supposed to be proportional. And sure enough, they do. It's 0.67 equals 0.67. So that's a really good way to make sure you've solved correctly. Let's do another one. So we just have a bunch of examples for you guys to practice. And I know I say this all the time. Don't forget that you can pause this recording at any point. You can even pause the play posits if you're watching the play posit version. All right, let's set it up. So x over what in shape number 2? 25. And then I'm going to use the 12 because it matches with the 15. I really can't use the 24 because it doesn't have a partner over here. So he's kind of useless to me right now, just for now. There we go. Once you have your proportion set up, we can cross multiply. 25 times 12 equals 15 times x. Let's see what 25 times 12 is. That's 300. And then we're going to divide both sides by 15. And you get x equals 20. Just like we did before, you could definitely plug that in and make sure that the fractions are in fact congruent. All right, the next example, let's do 10 over x equals 8 over 4. In this case, we could have also done 14 over 7, right? We have a lot more information in this one than we have the previous ones. So you can choose any pairings of sides that you want. The only reason we didn't choose the 24 here is because, again, it didn't have a partner. All right, so we got 8 times x equals 4 times 10. 8x equals 40. Divide by 8. That's just 5, right? X equals 5. We can plug it in for x and make sure. And you get 2 equals 2. We could even check that third side. It would be 14 over 7. That third ratio, and that is also 2. So there we go. We just proved that these are similar because they have those proportional sides. 2 more examples. We're going to have, let's see, let's go this shape to this shape. We're going to have 12 over 6, because those are the long bases, equals x over 5. We don't know. So we have 12 times 5 equals 6 times x. That's 60 equals 6x, and then we'll just divide by 6. X is 10. All right, last one on this page. Let's go shape 1 to shape 2. Why not? We'll change it up. So let's see, x over what? Well, we know this is sort of like the height, if you will. It matches up to the 35, right? And this is sort of, if we knew this was a 90-degree angle, we kind of would call this hypotenuse, right? But that's the slanted side. So this matches with 63. So 54 over 63. So we have 35 times 54 equals 63 times x. I'm going to grab my Desmos calculator. These numbers are strange. That's okay. And then we'll divide both sides by 63. And you get 30. It comes out pretty. X equals 30. I'll put it up here. All right, 2 more and then we are done. I call this a challenge, but I know that you guys can do it. The only difference here is that instead of having just x, now you have an expression with more than one term, right? We have a 2x plus 4 here, but you're going to solve it the same way. So we're going to do, it's kind of up to you. There's lots of options here. We know we have to include this side because that's the one we're looking for. So 2x plus 4 over 45 equals, we have to use the 16 because there's nothing else on this shape, and that matches with the 40. Okay, now we're going to solve this the same way, but it's just going to take a little extra step here. 45 times 16, and then 40 times the entire numerator. So you got to put that in parentheses. You have to make sure to multiply 40 times everything. So I'm going to come up here. 45 times 16 is 720. And then whenever you have a number in front of the parentheses, remember we distribute. So 40 times 2 is 80. And 40 times 4 is 160. There we go. Now we're going to keep solving for x. So I'm going to subtract 160 from both sides. Bring down the 80x. And we end up with what? Let's see. 560. Last step to get that x by itself, we're going to divide by 80 on both sides. So x equals, I'm using my Desmos for this, 7. All those numbers and you get 7. So sometimes it'll say like find the side length. So then you'd want to take that 7 and plug it in here for x. Oh my. And you would get 14 plus 4. Wow, it just keeps connecting the 4s automatically. That is bizarre. 18. All right, let's do this last one. And I'm going to, because I can very easily, I'm just going to put it on a new screen so I have lots of space. You guys should hopefully have enough space on your paper. If not, you can grab more paper. Okay. So here we have the expression 8x minus 2, and we'll put that over the 63. And then we'll use 42 and 49. We can't use this 49. I mean, essentially it is the same number, but because we don't have the base here. So you want to use what you have. So let's cross multiply 63 times 42 and 49 times all of this. 8x minus 2. Grab those calculators. These numbers are getting bigger. So if you have the tool you should use it. I mean, you don't have to. I got 2,646 on our left side, and then we'll distribute the 49. So 49 times 8 is 392, and 49 times 2, oops, is 98. Oh, what just happened? All right, let me erase this. There we go. Now we just got to solve for x. So we're going to add 98 to both sides. Bring down the 392. This is old school algebra at this point. Hopefully you guys are feeling super comfortable in remembering solving equations. Not, then you're going to want to practice that or reach out for help for sure. And then we are just going to divide because this is 392 times x. So the inverse or opposite of multiplication is division. So x equals 7. That's hilarious. It's the same 7. Oh my goodness. All right, you guys, thanks so much for watching. I will see you in class. And that's it for semester 1 material. So we're going to be reviewing for the exam, and then we will likely get a sneak peek of semester 2 if we have time. Bye, everybody.